This is problem 21 out of section 3.3, and this is very similar to problem number 21 and 3.3 in the textbook. This is problem number 21 in the exercise set, and it's similar to number 21 and 3.3 in the textbook. So what we're asked to do in this problem is to, if you look near the last sentence, says to how many cans of each dog food should this fellow give his dog each day to provide the minimum requirements at the least cost, right? So we want to minimize cost here. So what I'm going to do here is I'm going to let X equal the number of cans of brand A and Y be the number of cans of brand B. And as I read through the problem, it's pretty much in every sentence. If we look for brand A, that gives us, each can gives us 3 units of protein, 1 unit of carbs, and 2 units of fat, and it costs 80 cents. For brand B, we get 1 unit of protein, 1 unit of fat, 1 unit of carbs, 6 units of fat, and the cost of that can is 50 cents. And the requirements for protein, I'm going to leave a little space here, is 6 units, 4 units of carbs, 12 units of fat. But what I'm going to do here is that's a requirement, so that's the minimum requirement. So we're going to have to go greater than or equal to. We need at least 6, at least 4, at least 12. So here's what we want to do in this problem. We want to minimize our cost, and our cost is coming right from here. So we have 0.80 of these x's plus 0.50 of these y's. So what we want to do is minimize, I'll even spell it correctly here. We want to minimize our cost subject to here's our constraints. We have 3x plus 1y greater than or equal to 6. We've got x plus y greater than or equal to 4, and then we've got 2x plus 6y greater than or equal to 12, and of course we've got x greater than or equal to 0, y greater than or equal to 0. Now what we need to do is to graph these three inequalities to get our feasible set. So I've done a few of these, and I've noticed that in order to get a reasonable graph, if we make our coordinate axes pretty big, we have a better chance of getting a decent looking graph. So here's x and y. I'll make them kind of big. Now I want to graph each one of these, so why don't we do this? I'm going to label this first inequality 1, the second one 2, the third one 3, and let's get the graph of each. So in the first one, if I let x equal 0, so put 0 into the first one, put 0 right here, the 3x is 0, and then I get y equals 6. And likewise, if I put y equals 0, 3 into 6 is 2. There's the first. And for the second one, if we put in 0 for x, now I'm putting that right into the second one. So if x is 0, y is 4. And similarly, if y is 0, x is 4. And for the third one, if we choose x to be 0, so I'm putting that 0 right into that x into the third, and 6 into 12 is 2. And if I let y equals 0, I'll get 2 into 12, which is 6. So now as I graph these, I notice I need to get my numbers on here, on these axes. So I notice that the biggest y value I have is 6. So I'm going to put the 6 up here at the top. Let me get that. 6 at the top on y. The next value of y is 4. That's about 2/3 of the 6. So maybe it's kind of here. That'll be the 4, and then the 2 is 1/3 of the 6. So let's put the 2 down here, and we'll have 2, 4, 6. Looks pretty good. Let's do the same for the x's. And for the x's, the biggest x that we have, there's a 2, a 4, and another 6. Oh, we're going to get the same values here. So let's put the 6 way out here. The 4 will go here, and the 2 will go here. Now, let's get our line. So what I see is that the 6 on the y, the 6 goes to the 2, so let's get that line. So the 6 goes to the 2, right, and that's coming from line number 1. In line number 2, the 4 goes to the 4, so let's get that one. The 4 goes to the 4, right, that's on line 2. And in our third one, the 2 goes to the 6. So let's draw that line. The 2 goes to the 6. There's line 3. Now, these inequalities are all greater than. So if we run our test, if you do a test point 0, 0 down here, substitute the 0, 0s in here, we will get 0 greater than 6. That's false. These are all false statements. So 0, 0 is not in the feasible set. So since they're greater than, our set is going to be out here. Let's do it this way. We're going to get our feasible set out here. So that's our feasible set. And then what we need to do is get this point right here, that ordered pair, that ordered pair here, that ordered pair here, and this ordered pair out here. Now what we need to do is get the coordinates of these points here. We need the coordinate of this one, this one, this one, and this one. Now this one's easy enough. This is the y-intercept, so x is 0, y is 6. This one right here, now this is the intersection of line 1 and line 2. So line 1 and line 2. So if we set up this system with line 1 and line 2, and we use Gauss-Jordan that we discussed back in chapter 2, we're going to get this point right here. We get x equals 1, y equals 3. Now, to get this point right here, we see that that is the intersection of this line here, which is line 2. Here's line 2, and line 3, and here's line 3. So we're going to solve the system with this line 2 and line 3, right here, line 2, line 3, and if we apply Gauss-Jordan, as we did in chapter 2, we're going to get x is 3 and y is 1. So let's put our points in. From here, we'll get 0 and 6. And if we put 0, 6 into x equals 0 and 6 into here, we are going to get 3. And our next point, if we choose this one right here, we've got 1 for x, 3 for y, and putting those values into this expression right here, we're going to get 2.3. Then, putting in the coordinates of this point, which x is 3, y is 1, and substituting in, we're going to get 2.9. And finally, if we put in the coordinates of this point right here, x is 6, y is 0, 6 and 0, we're going to get 4.8. So taking a look what we've got, this is our minimum right here, right? 3, 2.3, 2.9, 4.8. That's the smallest value, and that occurs when x is 1, y is 3. So we're going to write our conclusion like this. We're going to say that the cost is minimum at $2.30 when Mr. Smith feeds his dog 1 can of brand A and 3 cans of brand B each day.